This is a quick video on how to calculate the price elasticity of demand. That's a really fancy way of saying when I change the price, how much does demand change in response? So you can imagine maybe a situation in which I change the price just a little bit and a lot of people don't want my product anymore. Or maybe there's some products where I can change the price a whole lot and people will still buy it no matter what. This is the concept of elasticity, and we'll talk more about this in class. What we want to do is we want to get a calculation, a number for the price elasticity so that we can see just how much demand changes each time we change the price. And that's not going to be constant. As we change from $4 to $5, that might be a different elasticity than when we change from $5 to $6. So we're going to look at an entire demand price and demand schedule, and we're going to calculate the elasticity for each of those price changes from point to point to see how the elasticity changes over time. So let's jump into our example.
Okay, here we have a price and demand schedule for some good. So along here we have incremental increases in the price by $2, and then we can see how the demand for those units changes as the price goes up. So what we're wanting to do here is we want to know for each change in the price, how much does demand change? And so to do this, we're going to calculate the price elasticity of demand. How elastic is demand relative to the price? So to do this, we have a formula here. We use the Greek letter epsilon to denote elasticity. So elasticity is equal to negative, so don't miss this little negative sign in front. And we want the percent change in demand, and then we divide that by the percent change in price. And what that does is it will return back to us a number, and that number tells us the percent change in demand that follows a 1% change in price. So if the price changes 1%, what percent change do we see for demand? Now, elasticity is going to range from 0 to some big number. So if it's 0, that means that it's perfectly inelastic. It means that changes in the price doesn't do anything to the quantity. You can keep raising and raising and raising that price, and nothing's ever going to change it. If it's less than 1 but greater than 0, it's still inelastic. It just means that it changes very little when you change the price. If it's exactly 1, that means that they're unit elastic. It means that they change at the same rate. So 1% change in the price is going to result in a 1% change in demand. And then if it's greater than 1, we say it's elastic. That means that it changes quite a bit. If you change the price, you're going to see a big change in demand, more than the percent change in the price. And that number can just keep going up and up and up to infinity. Just the larger it is, it just represents the bigger and bigger and bigger changes of demand. Okay, so coming back to our example here. So we want to calculate the percent change in demand, the percent change in price, and then we're going to use these to calculate epsilon, which tells us the price elasticity of demand. So if you remember, for a percent change formula is new minus old divided by old. So if we want the percent change in price, we're going to say equals new minus old. And we're going to put these in parentheses, divided by old. Okay. So that's the percent change in price between these two, this from going from 10 to 2. Okay. And we can go ahead and drag this down. And again, this goes all the way down. So this last one shows new minus old divided by old. Okay, so we've got our percent changes in price. We want to do the exact same thing for demand. Okay, so we go new minus old, put parentheses, divided by old. Okay, now you'll see that this is negative, suggesting that it goes down. Okay, and that's why in the final formula we're going to include a negative in the formula, because when you divide this by this, it's going to have a negative number. We don't really need that negative number, so we just put a negative sign to change it to a positive for this one. Okay, so again, epsilon is equal to negative the percent change in demand divided by the percent change in price. Okay, so we can see that moving from $10 to $12, the elasticity here is 0.5. Now going back to our measures here, if it's less than 1, we'd say it's inelastic. So changes in price don't result in very little changes to quantity. Okay, now let's just drag this down and see how that changes as we go throughout the price. Okay, wow, so it's not constant. So when you go from 10 to 12, it's inelastic, but going from 12 to 14 is unit elastic. It means that you see a same percent change in both price and demand at this point in the schedule. And then as we continue to increase that price, it actually gets more and more elastic. So even though across all of these, you're always just increasing by $2, the change in demand is much more than what we're changing in the price. We're losing more demand than we are gaining in the price there. Okay, so you can see that this number just keeps getting higher and higher. It just means that it's more and more elastic. It responds more to the price changes than it did clear up here, in which it was only 0.5. Okay, so we're going to use this to talk about the extent to which changes in the price will change demand. That has a lot of policy and managerial implications that we'll talk about later in class. But hopefully this just gives you a quick little overview of how to calculate this.